Hello and welcome to Distributed Systems and Blockchain in the News. My name is Thomas Bocek, and this week we have quite some news. In lecture 4, I was talking about web push notifications for iOS, that they will be back for EU users. They were removed previously for users, now they're back. However, this caused some more discussions as the trigger seemed to be the DMA Act by the European Union that promotes competition in the online markets. And this new law is designed that smaller companies can enter the market and to prevent single corporations from controlling entire market segments on their own. And this article here criticizes Apple's monopoly on iOS app distribution despite the new EU regulation intended to promote competition. Apple's new model for alternative app marketplaces is seen as deliberately unattractive, maintaining its monopoly and high fees. And also, this article argues that Apple uses security as a pretext, but points out that Mac OS allows direct app downloads without security issues, suggesting that a similar approach could work for iOS as well. This article also discusses how Apple's policy harm privacy, security, and economic diversity, calling for a more open distributed model. Quite an interesting article. The next article is quite a technical article. It's about exploring strategies for achieving zero downtime upgrades of stateful systems, focusing on minimizing service interruption during these software updates. And it's the following article here. And it highlights Erlang OTP's hot swapping feature as a model for seamless upgrades and discusses the importance of features such as backwards and forwards compatibility, atomicity, and the ability to downgrade. The author proposes using state machines for representing programs and upgrades, outlining a method for implementing upgrades that ensure type-safe state migration and compatibility across different versions of a system. As I mentioned, it's quite technical, but nevertheless quite interesting to have a look at. The next article is about how distributed systems may look like. It's the following article here. And in this article, Meta is showing how their upcoming computing infrastructure for Llama 3 may look like. And I'm very impressed by those numbers. And Meta, they have announced the construction of two large-scale AI clusters, each equipped with roughly 24,000 GPUs to support AI research and development, including Llama 3 training. Llama 2 is already out there, it's widely used, and this is about the upcoming Llama 3 model. And these clusters built on open compute platforms and PyTorch mark significant investments in AI hardware infrastructure aimed at advancing towards artificial general intelligence. And the design emphasizes network efficiency, storage solutions, and performance optimizations, facilitating the development of advanced AI models. Meta's commitment to open innovation is highlighted by contributions to the Open Compute project and PyTorch, aiming to foster a transparent and collaborative AI development environment. And indeed, if we look at OpenAI, they seem to be more closed than actually Meta is. With their Llama, they released the models, we can use them. People train on these models and extend those models, which is currently not possible with OpenAI. And what's impressive are the numbers. So they mention here they have over 350,000 H100 GPUs. And if we look at the price of such a card, it's roughly 40,000. Here is a bit more, here is a bit less. So I expect they get it for half the price. And if they get it for half the price, um, they are investing roughly 8 billion US dollars just for their hardware for these NVIDIA GPUs. And I think this is a really impressive number. The next article is about scaling. It's about Figma. And this article details Figma's 9-month journey of implementing horizontal sharding, it's this article here, to scale its Postgres database infrastructure. And this approach was chosen over vertical partitioning and other scaling strategies due to Figma's rapid growth, which resulted in a 100 times larger database size since 2020. And the team prioritized minimal developer impact, transparent scaling, avoidance of backfills, incremental process, reversible migration, and strong data consistency, and leveraging, of course, internal existing expertise. They explored various sharding solutions before customizing one to fit Figma's needs, resulting in a successful horizontal sharding that promises nearly infinite scalability. And what caught my attention was that they wrote here, in 2020, we were running a single Postgres database hosted on AWS largest physical instance. And by the end 2022, then they added horizontal scaling with a distributed architecture. I don't know the exact numbers in 2020, but I saw this figure here that at some point in time they have 3 million monthly users, which is quite a lot. So I expect in 2020 they had roughly 1 million monthly users. Now, Figma is data heavy, meaning a project can easily store gigabytes of visual data. And this brings me to my point. Machines are fast today. If you don't have a million of users that store gigabytes of data, you probably don't need to scale. And for simple services, one machine, fast machine, is certainly enough. The next article is about fast machines as well, and it discusses Postgres evolution to a comprehensive data management framework, or the author argues that it's a comprehensive data management framework, and challenging the traditional OLTP and OLAP database roles. OLTP stands for Online Transaction Processing, and OLAP stands for Online Analytical Processing. And it highlights this article here, and it highlights Postgres SQL's advancements in analytics, particularly with extensions like Hydra, Timescale, DB, and Citus, and the new tools like ParadeDB and DuckDB, enhancing its OLAP capabilities. And the author argues that PostgreSQL, due to its extensibility, open source nature, and the growth of powerful extensions, is set to dominate various database niches, merging OLTP and OLAP functionalities and simplifying the data management landscape. And what caught my attention is this graph here. So the following graph that shows that I/O bandwidth, it's actually the PCI buses, that doubles every 3 years. I found the original article, and it's the following PDF here. And this shows impressively and that also I/O bandwidth gets faster. And another sentence that caught my attention is this one. Most people don't have that much data, and most data is seldom queried. So most of the time, you don't need to scale horizontally. So a fast machine is actually enough. In lecture 4, I presented containers and VMs. And I recently came across this nice YouTube video. It's a nice summary about Docker and VMs. It's only 8 minutes. The author or this YouTuber, he explains it quite fast. So there's lots of information, but nevertheless, I think
Welcome
it's
to Docker 101. If your goal is to ship
worth
software in the
have a
real
look
world,
at.
one of the most powerful concepts now, and software to physically handle the incoming request and increase its RAM and CPU.
So take a look at it, and this tells you in 8 minutes what containers and what VMs is on a high level. The next article is about Tor. It's the following article here. And the Tor project has introduced WebTunnel. It's a new bridge designed to evade censorship by mimicking HTTPS traffic, making it difficult to block without affecting a vast majority of web connections. This approach is especially crucial in countries with strict internet censorship. WebTunnel wraps Tor connections in a WebSocket like HTTP layer, making them appear as regular web browsing to outside observers. And to use web tunnels, users must manually add bridge addresses to their Tor browser settings. And this initiative is part of a broader effort to combat the internet censorship and ensure access to free information, and has seen deployment in various regions, though it faces challenges in some areas like Iran, while web tunnels work great in regions like China and Russia. Currently, it doesn't run well for users in Iran. And the last article, it's about legal judgment. It's about Satoshi Nakamoto, who is, or actually who is not. And Satoshi Nakamoto is not this guy here. So this last article reports on a legal judgment regarding the true identity of Bitcoin's inventor Satoshi Nakamoto, which it's still unknown who this inventor is. That's a pseudonym, and we'll talk about Satoshi Nakamoto and Bitcoin in the later lectures. The central figure, this guy here, he's an Australian computer scientist, Craig Wright. He claimed since 2016 to be Satoshi Nakamoto, the creator behind Bitcoin, and now a British court found Wright's behavior to include dishonesty and forgery, even accusing him of creating forged documents during the trial. And ultimately, the judge ruled that Craig Wright is not Satoshi Nakamoto, dismissing his claim to have invented Bitcoin. And the judge emphasized that the decision was reached quickly due to the overwhelming evidence against Wright. So, unfortunately, we still don't know who Satoshi Nakamoto is, but we know it's not